Good morning friends. I hope you are following the thermodynamic video lectures thoroughly. In the last class what we discussed means we discussed the Cp and Cv and different parameters, adiabatic constant. These values are these parameters we discussed in the last class. Today our goal is to find out the different parameters when the two gases are mixed together. What are the parameters basically we are discussing here means the total number of moles of the mixed gas, the total molecular weight of the mixed gas, the molar constant, the specific heat value of the gas at constant volume, the molar specific heat constant value of the gas at constant pressure, the adiabatic constant of the gas. These values are we are going to find out the for mixed gas, not a individual gas. Now let us assume a gas, there are the two gases are separately separated in a same volume with a small thin layer. This layer can be removable when we are performing the experiment. Now let us assume the gas 1 have the number of moles is the N1 mole, gas 2 is having the total molar weight of the gas 1 is having the M1. So the gas 1 having the molar specific heat constant at constant volume having the Cv1, the Cp1 is the molar specific heat constant at constant pressure Cp1, the adiabatic constant of the gas 1 is the gamma 1. Similarly the gas 2 is also here. Let us assume the gas 1 is indicating with one of the color. So let us assume this is the gas which is having with this color. So red color bubbles we are taking, this is the gas 1. The parameters are here. Now the gas 2 also having the another color. This is the gas 2 which is having another color molecules of the gas 2. Now when we are performing the experiment, the thin layer is removed. When we are removing this thin layer, the two gases are mixed together, then they are forming a different values of N, number of moles, molar weight and also a specific heat constant. So molar specific heat constant at constant volume, molar specific heat constant at constant pressure and adiabatic constant value of the mixed gas. To do this experiment, we need to follow a specific condition. The two gases are not reactive in nature. Then only we can use this formula. If the gases are reactive in nature, then we are unable to use this condition. Use this formula what we are going to derive now. Now as per our syllabus, we are dealing with non-reactive gases only. We are not dealing the reactive gases here. That means as we are performing the experiment, this layer is removed now. Now these gases, the layer is removed now. The gases are two gases are mixed together. Now gases are making a single gas. So this is the mixed gas because of we removed this one. So the mixed gases are mixed together. Now let us assume how many number of moles are available now. As N1 moles are available in the gas 1, N2 moles are available in the gas 2, the total number of moles are available due to the mixing of gas is the number of moles of mixing is equal to previous gas 1 number of moles N1, the previous number of moles of the gas 2 is equal to N1 plus N2. This is the number of moles of the mixing gas. We already know number of moles is equal to weight of the gas divided by molecular weight of the gas. So now N1, so now I am taking weight of the gas in grams, molecular weight of the gas or molar weight of the gas, molar weight of gas in grams. This formula we can use for find out the number of moles. In the similar manner, so the N1 is equal to the weight of the gas, let's assume the weight of the gas is equal to small m1. Let's assume this is the small m1 is the weight of the gas, then m1 divided by molecular weight of the gas is equal to m1. Here I used here m1, small m1 is equal to weight of the gas in grams. In the similar manner, what about the N2? N2 is equal to small m2 divided by capital M2. Now what is the total number of what is the total molecular weight of the gas, molar weight of the gas. So now molar, from this formula, number of moles is equal to number of moles is equal to weight of the gas divided by molecular weight. This formula we already know. So from this one, what I think, molecular weight is equal to molecular weight of the gas is equal to weight of the gas divided by number of moles. So will you please see this one, just I interchange this one, just I send this one. Now our goal is to find out the what is the molecular weight of the mixture of gas. Now I am taking the molecular weight of the mixture of gas is equal to M mixture. This is the molecular weight of the mixture of gas is equal to weight of the gas, total weight of the gas. Total weight of the gas means what is the total weight of the gas. Now let me take this previous formula. From this equation, the weight of the gas, first gas weight, how much it is having, weight of the gas first one is equal to, from this one, M1 is equal to N1 capital 1. From this equation what we will get, so M2 is equal to N small n1 into capital M2 we will get. So that is equal to, total weight is equal to M1 plus M2. M1 plus M2 is nothing but N1. This is equal to N1 M1 plus N2 M2. This formula we can use. Let me go to this one. So the weight of the glass is equal to small m1 plus small m2 divided by number of molecules is equal to number of moles is equal to N1 plus N2. But M1 is equal to small n1 capital M1 plus small n2 capital M2 divided by N1 plus N2. With help of this formula we can easily find out the total number of molecular weight of the mixture of the gas is equal to then N1 M1 plus N2 M2. Here N1 is equal to number of moles, M1 is equal to molecular weight of the gas of the first gas, that is equal to N1 plus N2. This is the formula for the first gas. We derived two formulae here. The first formula is nothing but the total number of moles in a mixture of gas is equal to N1 plus N2. The total number of the molecular weight of the gas, molecular weight of mixture of gas is equal to N1 capital M1 plus small n1 and small n2 into M2 divided by N1 plus M2 we are getting. Now our goal is to find out the remaining parameters. What we are going to remaining parameters means these two parameters we evaluated, then Cp, Cv and Cv, molar specific heat capacity at constant volume, molar specific heat capacity at constant pressure, and adiabatic constant of mixture of gas we need to find out. Now let me go to for that one also. Now our goal to find out this one, as the gas is not interacting to each other and also the bounded, the system is separated, it is an ideal system, it is a isolated system here. This is the gas, this system is isolated, that means the system temperature may not be changes due to, because of there is no, this is the adiabatic, it is the isolated system, the walls are adiabatic. Now gas 1 and gas 2 are mixing together, the walls are adiabatic. As the condition of the adiabatic walls, there is no exchange of heat from the surrounding or surrounding to, so from system to surrounding, there is no exchange of between, then the temperature of the system must be maintained at constant because of the adiabatic walls. This is the adiabatic walls. Now the temperature is maintained at a constant temperature, T must be constant. So when the T must be constant, then the internal energy of the system before the interaction of the gases, so they are not interaction, they are not chemically reactable gases. Before the mixing of the gases and after the mixing of gases, the total internal energy of the system of the gas, the system must be maintained constant. That means we are taking the one of the important condition. So the internal energy must be made constant. The internal energy must constant before and after mixing of gas. So then what we can take, so then the internal energy of the after mixing, internally of the mixing, so the internal energy of the gas 1 and internal energy of the gas 2, that must be equal, as there is no interaction of heat energy from surrounding to system before and after. Now we are very familiar about the internal energy formula. Internal energy formula, U is equal to number of moles and specific heat, molar specific heat capacity at constant volume and temperature of the gas. Now with help of this one, as U mix U1 I can write is equal to N1 CV1 into T, and U2 is equal to N2 CV2 into T. In the similar manner, U mix is equal to N2 CV mix value into T we can write. So with help of the formula, U mix is equal to U1 plus U2, formula I am using, that is equal to, sorry, this formula is equal to N1 plus N2, thus two gases are mixed there. So N1 plus N2 bracket into CV mix into T is equal to U1, I am substituting all values, N1 CV1 T plus N2 CV2 into T. T is the common term here, T I cancelled here. Now our goal is to find out the CV mix value. So then CV mix, that means molar specific heat capacity of the mixed gas at constant volume is equal to the remaining terms here, N1 CV1 plus N2 CV2 divided by, so this term is going this side, that is equal to N1 plus N2. This is the formula for the the mixing gas molar specific heat capacity at constant volume. Now how many parameters we concluded, means here we concluded CV, evaluated the CV value, CV of mix value also we evaluated. Now let me go to the CP mix formula, CP mix formula, derivation of the CP mix formula. CP mix is equal to question mark. So we already known about the CP mix is equal to CV, the relation between the CP and the CV formula we already known with help of the Mayer's relation. So CP minus CV is equal to capital R, which relation? It is the Mayer's relation. Mayer's relation. This formula is, this relation is given by the one of the scientists, that name is Mayer. So then with help of this one we already known about this one, send this CV this side and R this side, that is equal to CP minus R is equal to CV. Just I am sending R this side, I am sending this CV that side. So we already known the formula for the CP mix. CP mix is equal to N1 CV1 plus N2 CV2 divided by N1 plus N2. This formula we are having. So this formula can be written here like this, N1 CV1 divided by N1 plus N2 plus N2 divided by N1 plus N2 into CV2. This formula can be written like this. Now I am substituting CV mix in terms of let me take with help of this one, CP1 is equal to, with help of this formula, sorry, CV1 Now I am taking this relation with help of this one. CV1 is equal to CP1 minus R, ideal gas constant we are repeating. In the similar manner, CV2 is equal to CP2 minus R. In the similarly, CV mix is equal to CP mix minus R. This formula we can write. Now where these constants are available, I am substituting these values in the below equation. Here Cp mix is there, I am substituting this value, that is equal to Cp mix minus capital R bracket open is equal to then I am substituting here. Otherwise I will send this n1 plus n2 this side. I am sending n1 to n2 this side. So n1 plus n2 this side is equal to, now I am substituting this remaining term. Let me take one more formula where I am taking, so Cv mix is equal to n1 Cv1 plus n2 Cv2 divided by n1 plus n2. I am rearranging this equation. Cv mix into n1 plus n2 is equal to n1 Cv1 plus n2 Cv2. This formula we are having. Just I am substituting the values of Cv mix and Cv1 Cv2 in terms of Cp values. Then Cp mix minus capital R into n1 plus n2 is equal to n1 Cp1 minus capital R plus n2 Cp n2 into Cp2 minus capital R. Just I substituted where Cp is there in terms of Cp. Cv is there in terms of Cp, I substituted. Then common multiplication about this one, Cp mix into n1 plus n2, this is the value, minus R into n1 plus n2, this side values, that is equal to, now I am multiplying this value to here, that is equal to n1 Cp1 minus n1 capital R plus n2 Cp2 minus n2 capital R, this value I am getting. So now I am taking n1 Cp1 plus positive values I am writing in a separately, n2 Cp2. In this and negative values I am taking the negative is the common term in these two terms. So I am taking negative is the common, and also R also I am taking common. So where R into n1 plus n2, this is the value. In the left hand side we are having R plus minus R into n1 plus n2, right hand side minus R into n1 plus n2, both are cancelled. So now our goal is to find out the Cp mix value, then Cp mix is equal to, from this one Cp mix is equal to, so it is the multiplication, it will go to this side, it will go into the denomination, that is equal to n1 Cp1 plus n2 Cp2 divided by n1 plus n2. This is the formula we are having. Now we evaluated another relation for the mixed gas of Cp mix value we evaluated. Now let me go to the for another one. Our goal is to find out the gamma mix value. So we are taking the first relation where Cv mix is equal to n1 Cv1 plus n2 Cv2 divided by n1 plus n2. This formula only we are taking. We have the formula for the gamma in terms of Cv. So Cv in terms of gamma. Cv is equal to R divided by gamma minus 1. This formula is known. Now Cv1 is equal to R divided by gamma 1 minus 1, Cv2 is equal to R divided by gamma 2 minus 1, Cv mix and similarly Cv mix is equal to R divided by gamma mix minus 1. We will get like this. Now with help of this one I am sending n2 minus n1 plus n2 this side, that is equal to Cv mixed value into n1 plus n2 is equal to n1 Cv1 plus n2 Cv2. This is the value. Just I am substituting the Cv mix value in terms of gamma. So R divided by gamma mix minus 1 into n1 plus n2 is equal to n1 Cv1 is equal to R divided by gamma 1 minus 1 plus n2 into R divided by gamma 2 minus 1. This is the formula we are having. In this one, R is the common term. I am taking this one. With help of this one, we can easily find out this value of this one. So now, so 1 by gamma mix minus 1 is equal to, now I am sending this n1 plus n2 this side, 1 by n1 plus n2 bracket open, n1 divided by gamma 1 minus 1 plus n2 divided by gamma 2 minus 1. This is the formula we are having. So now we evaluated the different parameters in the when the two gases are mixed together, and also they are non-reacting in nature. So let's we start once again. We are recalling this, what we are going to find out. So we evaluated the CV value, CP mix value and gamma mix value when the two gases are mixed together. I hope you are enjoying the lecture. So if you are feeling that these lectures are useful for your academics or any preparation for competitive exams, I am requesting you, please subscribe our channel and also share these videos to your friends which they are needed. Thank you for your support.